don't promise to be as voluminous as Eric, but I'll try to at least be engaging. So, our cultural heritage is steadily being digitized. There's efforts ongoing at practically all of the major libraries, archives and museums to capture digitally our works such as this from history. This is a manuscript at Harvard University. But, and which is fantastic, but to what end? At the moment, we have these things, silos. And they're full of fantastic images, but how do we get them out of those silos? All those silos are unconnected. You have to know where this place is in Idaho in order to go and get the grain out of it, the images. The images have varied levels of descriptive metadata. Some are very well described, some much less so. But the transcription of the text is almost non-existent. Right? You would not be able to do a full text search to find those images. Licensing is an issue, especially with silos, where we don't know how or if we can reuse those images once we find them. And a quick shout out to Europeana and DPLA for the work that they're just starting on in trying to move that area forwards. So one of the side effects of having these non-interoperable silos is that we also have many different viewing environments, and they're all tightly bound to the silos of images that they're interacting with. That makes them costly to maintain and to update because everything is a one-off. If you have a manuscript viewer, that's going to be separate from your archival viewer, going to be separate from all of your other collections. It also leads to user frustration because once you get to this interface, it's going to be different from every other interface you've ever used, just to interact with one collection. The silos then, I mean, that would be an easy solution to that. We could all use the same image viewer with the same client system, but because the silos are not interoperable, we can't do that. It's impossible to collaborate. So how do we cooperate? How do we collaborate on that sort of thing? So remember, this is the key thing to keep in mind. This is the valuable content, the grain inside the silos, the images. That is an ugly construction that is the blight on the landscape of this otherwise beautiful picture. That's what we want to break down. Right, and I'm going to try and swap in and out between live and not live, and that needs to be slightly smaller. Making it even harder to not click on the X's when I want to swap between tabs. Okay, so I typed that in ahead of time rather than trying to type that in live. So here I do a search for Chronicles in Europeana, but we've already heard talk about their data model. Let's have a look at this one. And it's got the image over here. It's public domain, so we know what license it is, that's great. But Europeana only has the metadata, it doesn't have everything. So we have to go out and click this view item link to see what it's like in Manuscriptorium, at the National Library of the Czech Republic. Oh, wait, more metadata. Okay, so now I look around, where do I go? Browse facsimile. I go somewhere else. And now I can interact with the image. So, okay, do I zoom? No, I can't just scroll in. Do I double click? No. How do I zoom in on the image? I can go over here. Oh, I see, finally. Right, there's the stuff. And then there's all of these little panels everywhere. Okay, great, all right. So, one issue with Europeana, and we've been talking about this for quite a while, is the user ends up outside of their context. They end up in the silo. And then it's very hard to get out. How do I get back to Europeana from here? I have to reload the home page. We've also talked a little bit about DPLA this morning. And we can do the same sort of thing. Search for a Bible in the Houghton Library at Harvard. The advantage of doing demos like this isn't my stuff, so if something goes wrong, I get to love other people. So I'm even more impressed by Eric doing all of his own. So let's have a look at this Bible NT. So no image, minimal metadata, and I can go and view the object in its original context. Okay, and again I have to search around where do I see the full link, and of course it's grayed out because I've clicked on it before, and we end up in a totally different viewer. And here are the icons for zooming in and out. So here's the quiz. What's the similarity between this user interface and this user interface? Right? The only thing which is similar is the grey and red colouring scheme. So let's go back to DPLA. Let's go back to DPLA. And we'll do a search for waiting. So here we have another example, and in this case it's over at the University of South Carolina, and this uses their content DM system. Here it's a slider to zoom in and out. All right? So this is one leaf of a manuscript which in 1940, and I'm an atheist when it comes to demo gods. Yeah. And here is the screenshots that I'm not going to go through. A manuscript which was in one place in 1940, it was owned by this guy, Otto Ege, and a colleague of ours at Stanford, Ben Alberton, is a manuscript scholar. So a biblioclast is someone who tears pages or otherwise destroys books. So boo, thumbs down to these guys. Okay. So in 1940 he had this manuscript in his collection, and he split it up and sold individual pages to individual institutions, and now it looks at least as bad as this. We know of 33 institutions in which that have some number of leaves. And you can see, here we are, actually Stanford has some leaves. If I switch back again, we can see. And once again, the only similarity is that we have some red and we have some grey, but the user interface is otherwise completely different. Okay, so how are we going to fix this? Stanford likes to be part of things, like the red-grey colour scheme. But we also like to come up with more interesting solutions, such as the International Image Interoperability Framework. So there are 3 parts to IIIF, or IIIF, or IIIF. I prefer IIIF. It's a community. We have several national libraries, Europeana, DPLA, Art Store, most of the Ivies and peer institutions. It's also 2 APIs, an image API for interacting with the images directly, and a presentation API for interacting with the description of the structure of the object, plus the 3rd part, software. So just to quickly show you the list while we're here. If you want to join, seeing as we're on this page, we have a Google group, IIIF Discuss. Please join to discuss. So I won't go through all of the list of institutions, but essentially the IBs plus many national libraries plus European DPLA and some more. Okay, so the two APIs. Rather than swapping back to my slides. So the current state of the image API is final draft for version 2.0. So the current is 1.1. In 2 weeks' time, we'll bake this one. There is one minor change to one of the APIs that we're going to make before that. So the image API lets you get at pixels directly. It's not metadata about the pixels, so it's not linked data itself, although there is a part of it that is linked data, which I'll get to. The main part is how do I interact with the image in order to do clever things with it, so that we can build viewers that do interact across those silos. The order of operations for the API is how the URI is laid out. So first of all, we have an identifier for the entire image. We can then select a region of that image. We can say, I want it at this particular size. So we've got the region, we slice it down. You can mirror it, flip it. You can rotate it, and then you can ask for it in a different quality, such as grayscale or bitonal. So, and now I am using my own code, so if something goes wrong, it is my fault. So this is one of the images from that manuscript that I was showing you before. And it is big, as you can see. It's 4,000 pixels by 4,000 pixels, give or take. So we can, this is the URI, so the region is full, the size is full, there's no rotation, it's the default quality, so color, and it's a JPEG. We can say, I want to see a particular region, such as the top left-hand corner. So this is X, Y, so 0, 0 is the starting point, width, height. And we'll get back a 512 by 512 block of the image. That's a bit complicated to remember, but we can do the same thing with percentages. So this will be 20% in, 20% down, 20% wide by 20% high. And we get a different chunk. So you might notice that we got redirected to this. So this is the canonical form of the URI, just to make it better for caching purposes, so that if you use this one, you're going to get a faster response than using the percent one. Okay, so what about slices? We can't actually see all of that, so let's make it a bit smaller. Say, about half size. So we can say percent 50. Okay, and now we've got the same part of the image, but reduced down to 50%. Perhaps we have a particular width that we're interested in. We can say give it to me at 500 pixels wide, and then comma nothing says, and you calculate the height. We could do the same for height, so we leave the width blank and say we want it 500 pixels wide, and again it changes up to the canonical URI. Maybe we have a 500 by 500 square space that we want to fit the image into. Right, so it could be a long, thin image, or it could be a tall image. Right, so we don't know which way to go. It should be 500 pixels wide, but then if it's really tall, maybe that doesn't fit in the square. So this exclamation mark 500, 500 means fit within the space. And of course it's the same 469 pixel image. Or if we know that we want to distort the image, so keep an eye on it, right? So we switch it out. So now it's exactly 500 pixels by 500 pixels. Let's make this a bit smaller so we can see all of it. Right, so we can flip the image, mirroring. We can rotate the image, so it's upside down. or we can rotate it by some arbitrary number, and we can do both at once. So now it's flipped and upside down. So this would be what you'd have when you did that sexy carousel viewer with the mirrored thing that sort of fades out below. What about having that as grayscale? We can have it, and this is going to be horrifically ugly, as bitonal, so just black pixels and white pixels, as expected.
So Rob, is it interpreting that based on the original? So so it's not that there was a save bitonal or a save pixel?
No, it takes the original. So there's a one master typically, one master image, though the API doesn't require that. It could be a composite of 16 different images. It then does the transformation on the original, caches that one, caches the copy in a disk cache in this particular implementation in the original. So,
Are your source image is JPEG 2000?
in this case it's a TIFF, but a lot of other servers do use JPEG 2000. And we can ask for it as a PNG or a JP2 or a GIF or etc. Okay. So that is the image API. Which I have here. Okay. So even though 2.0 isn't completely finished, we already have some implementations of it that you can get and use freely. So Loris is an image server from the Princeton University Library that supports 2.0 and 1.1. The OpenSeaDragon work, which originally came from Microsoft and was then open sourced, is already 2.0 compliant. Let's see, Reuven from the research arm of the Louvre is responsible for IIP server, and he announced today that it is already 2.0 compliant. Preload Jatoka is a product of Kevin Clark, which will be 2.0 imminently, he says. Python3f is the implementation I was just showing you, which is just a very simple, non-performant, but good for demos Python implementation. And there's various viewers as well. So let me show you this. So here is an image in the OpenSeaDragon viewer. This is a scroll that was digitized at Princeton, and it's pretty big. It, in fact, is really, really big. Right, so that's the full one pixel to one pixel width. And we can scroll along. We could do that all day because it's thousands and thousands and thousands of pixels wide. So that is a 2.0 OpenSeaDragon on top of a 2.0 box. We also have some other tools to help develop the work. So if I type in the URI to a validator for an example image, we can then run the tests. It goes off and pings it saying, hey, do you do this, do you do this, do you do this? And it'll give you the results for all the tests. There'll be perhaps one at the end that I don't support. No, good. So yeah, my reference implementation is in fact reference implementation. It gets green for all of the results. So that is the image API. There is one more thing that the image API has, which is information about how to interact with the image. Oh, one thing. We also have some shims. So Content DM actually has all of the features that you need to do AAAF. So we wrote a little shim that sits on top of it. You send it a AAAF URI, it turns it into a Content DM URI. So Content DM 6, I believe, or no, 7, the most recent one, can be trivially turned into a AAAF server. So, hey, Corey. We should talk. Frankly, America also has an image server based on JP2. So, hey, Kevin, we should talk about getting AAAF at the Library of Congress. There's also Cloudinary, J2K, Lurotech ICS, and the FSI image server that we've built shims for. So it's pretty easy to take existing infrastructure, put something in front of it to become compatible. And this is where I talk about JSON-LD. So, in order to come here to talk about linked data, not pixels, we have a linked data-based description of the image, so that we can then figure out, hey, how big is the image, what does the image server support, and so on and so forth. So it looks like JSON. So our developers are happy. If we go to the info.json and it says, hey, the pixels, it's 6,000 high and it's 4,000 wide. If you want to get tiles out of it, then you should use a width of 512 and a height of 512 to get those tiles, because that'll be efficient. If you want to get the full-sized image, here are a couple that will be efficient for you to use, maybe a thumbnail and a regular web size. And here is a profile of all of the things that we support. And the machine can then go to this profile, get the JSON, which is also linked data, and say, okay, now I understand what the server supports and how I can best interact with it. Okay, JSON-LD. And first, RDF-XML. So our keynote tomorrow morning is Manu Sporny. He is one of the geniuses behind JSON-LD. He wrote a blog post a couple of years back. RDF-XML was the semantic web's 3-mile island. I'm 100%, 110% in agreement with him here. So essentially, his thesis was, people looked at RDF-XML, they said, this is super complicated, it doesn't look like XML, what are all these URIs doing, and so on. They then said, I don't want to use that. RDF, right? Because they were conflating the RDF-XML serialization, which is terrible, with the data model, which is great. So essentially, like nuclear power, RDF not in my backyard. Right? I don't want to have that thing sitting there and it's going to explode and then I'm going to die. Right? So he has a few solutions for this, which is more the things on the left-hand side rather than the radioactive cleanup on the right. We should stop talking about RDF. We should just get on with doing stuff. That's basically it. We should focus on tools to make life easier for people, rather than talking about data models with lots of little circles and sticks and things everywhere. Yeah. We should focus on developers, because what we need are more tools and more visualizations and so on. And we should do more dog fooding. So dog fooding comes from an expression that we should eat our own dog food. Right? If we produce it, we should also consume it. So hence you should make your dog food pretty tasty, because you're going to have to eat it for dinner at the end of the day. Kingsley Eaterhen is actually really, really good at doing this, using his own stuff to make new tools. We should use our own tools. Right? So at Stanford, we have our image servers based on AAAF. So we're trying to do it as much as we can, and we'd encourage everyone else to do it as well. Okay, so JSON-LD is a serialization for the RDF data model. And I'm going to swap back and forth. It uses the very popular among developers JSON format. It's pretty easy to read, as I'll show you. And it's very easy to work with in browsers. It uses regular JSON idioms as well. And this is the key difference between RDF-XML and JSON-LD. RDF-XML is a hack, basically. It's how do I take RDF and kludge it into XML, because that's the tool that we have. Right. Whereas JSON-LD it ends up not looking like XML. JSON-LD looks like JSON. If you didn't know it was JSON-LD, it would just look like any other piece of JSON out there. Even better, you can often use existing JSON formats without changing a thing. Right? We can assign the predicates and the URIs on top of existing data and turn existing APIs into JSON-LD without changing anything. This was recently done by the GeoJSON folk in Sean Gillies. They've just come up with GeoJSON-LD, and it is identical, byte for byte, with GeoJSON. It does this by mapping the existing stuff into RDF in a separate file. So, some basics of how this mapping works. So a dictionary or an array, and if you glaze over at this point, I'll be coming out the other end soon, don't worry. So an object or a dictionary in JSON is a node in the graph. So it's a resource. The resource's URI is given in the @ID key. That's by convention. So if you happen to also have another, say, identifier property or ID without the @ you could also map that in the mapping. The other keys in the resource in the dictionary are the predicates. So I have a label Rob Sanderson, and I have a height of 183. So these are just literals. So a label and a height. Okay. So also note, 183 is not a string, it's a real number. So we don't have to do the RDF folk, the nasty data typing. Though when you convert it into RDF, you'll automatically get the data typing out. Most resources have a class, makes it easier to think about it. So there's another somewhat magic or conventional tag for it, which is @height.